Hello everyone, I hope you're all fine and well. This lesson is about integration. I will cover the first two parts of it, which is the integration as an opposite of differentiation and indefinite integration. First of all, before we start, I'm just gonna show you like some example of differentiation. So let's say the first function here is y equals x squared plus 3. So to find the differentiation for this function, what we do usually, like we'll say, write this as dy over dx, because y here is a function of x, yeah? So dy over dx equals, when we derive, we multiply by the power. So the power here on this question, the power here is 2. Okay, the power here is 2. Therefore, Okay, the power here is 2. Therefore, what we need to do, we multiply by the power. So we put the power 2 and x, and we take 1 from the power. So x squared take away 1 is x. So the derivative for it is 2x. Same thing here. The power is 2. So we multiply by the power. So dy, I'll write it down. So dy over dx equals 2x, and the derivative of the constant is 0. So as we can see here, both of them have the same derivative, which is 2x. Both of them are equal, although each one of them has a different constant. Okay, so in that case, so the gradient functions are both are the same, because the graph of y equals x squared plus 3 is just a translation of y equals x squared minus 1. So both of them are the same. The difference between them is just the translation. Okay. Now, indefinite integration is a reverse of differentiation. So when we differentiate, as we said, we multiply by the power and we divide by, we multiply by the power and we take away 1 from the power of x. For the integration, it's the reverse of differentiation. So that means instead of multiplying, we will divide. And instead of subtracting 1 from the power, we will add 1 to the power. So for example, if we have dy over dx equals 2x here, as this example, then to return this back as it was before we differentiate, we will add 1 to the power. If I add, so this is 2x means x to the power 1. So if I add 1 to the power, if I add 1 to the power and divide by the new power, because now it's 1 plus 1 is 2, so this becomes 2x to the power 2 divided by 2, and then basically we cancel these 2 and we end up with x squared plus c. This c, we call it the constant of integration, or it's they call it an arbitrary constant, yeah? So so as I said, 2x. So 2x, if you add 1 to the power, so this 1 plus 1, and divide by the new power, then we get x squared plus c, which is the constant of integration. Okay, and usually, so in that case, we would say the equation y equals x squared plus 3, it forms the family of the curves, because we notice from the previous two equations, both of them, when we differentiate them, we got the same answer, 2x. But both of them, each one of them has a different constant. So that's why we say y equals x squared plus c is the family of the curves. Okay. An example here, find the equation of the family. So they want the equation of the family, which is y, of curves which have a gradient function, that means dy over dx, equals 6x squared. Okay, so as we said, the integration is a reverse for the differentiation. So what we need to do, we need to add 1 to the power and divide by the new power. So if dy over dx equals 6x squared here, then to reverse the rule of differentiate, what we need to do, we add 1 to the power and then we divide by the new power and then add c at the end. Okay, so now this 6x squared, it's going to be 6x to the power 2 plus 1. So 2 plus 1 is a 3, then we divide by 3. So this is going to be 6x to the power 3 divided by 3, which is 2x cubed plus c. Right? And if you want to check your answer, you can differentiate this again. Yeah? So when you differentiate, you multiply by the power. So that will be 3 times 2, which is 6. X to the power 2, because we subtract 1 from the power. And the differentiation, the derivative of the constant is 0. So this is just a way for you to check. Okay, another example here. Find the equation of the family of curves with the gradient function dy over dx. So we have dy over dx equals a 3x minus 1, and therefore to integrate this or to find the family of the curves, all we need to do, we add 1 to the power and divide by the new power. So this is going to be, y is going to be 3x squared, because we add 1 to the power and then we divide by the new power, which is 2, minus 1x here and plus c. Why this minus 1x? The 1 becomes minus 1x. So maybe if you want to think about it this way, this minus 1, it means like minus 1 multiplied by x to the power 0. Yeah? So x to the power 0, if you add 1 to it, then and you divide by 1, you will get minus x to the power 1. So if you want to think about it this way, or just learn it as the integration of a constant is always x. Okay, or if it's 5, if it's 5, then it's going to be 5x. Okay. So for this one here, y equals a 3x squared over 2 minus x plus c, and notice that what happens to the constant terms, which is the minus 1 here, becomes minus x. Right, so we can only find the value of c if we have some additional information. At the moment, up to this stage, yeah, we can't find the value of c unless we have more information. Right, so finding the value of c. How to find the value of c? Find the equation of the curve which passes through the point 1, 2. So that's the x and that's the y, and has a gradient function given by dy over dx equals x squared minus x plus 2. So to find the equation of the curve, that means we need to integrate, yeah, or we do the reverse function, we do reverse of the differentiation. So basically, in that case, we will say if dy over dx equals x squared minus x plus 2, then y, we will add 1 to the power, so it becomes x cubed. Yeah, so we will add 1 to the power and we divide by the new power, minus x, we add 1 to the power. Yeah, so that's 1 plus 1, and divide by the new power plus this 2, it's 2x. It's because it was like x to the power 0 plus 1 divided by 1. So we will get this answer here. Plus c, which is the constant of the integration. So far we got the equation, the general equation of the general the general equation of the curves. But we want to find the value of c, because the point 1, 2, it's part of this. It's part of this curve. It's on the curve. Therefore, this will satisfy the values of x and y. So if we substitute by x, if we substitute 1 by x and 2 by y, and so this is the y here, and then we have all the values, all the numbers here except c, which is we don't know. After adding, subtracting and rearrange, we will get the value of c here, which is 1/6. Then, after finding the value of c, we can rewrite the equation in terms of x and y and the constant. So y equals x cubed over 3 minus x squared over 2 plus 2x plus 1/c. This was the constant. Okay? Right. Integration notation. We have already seen one way to write out an integration, which was the inverse of the differentiation, which we did, which we add 1 to the power and divide by the new power. Okay. However, a more common form of notation is used is this one. This is the most common notation of the integration, really. Okay, so this symbol here, we call it the integral sign, and we read this as dx, and it must be included to indicate that the variable is x. So if we have the variable here is x, this is meant to be dx. If the variable here is u, this meant to be du. Okay, so just to show, this is just to indicate what the variable is. Okay, so in full we say we are integrating with respect to x. Okay, so if we have dx here, that means we are integrating with respect to x. If that was if it's du, that means we are integrating with respect to u. If it's dy, that means we are integrating with respect to y, and etc. Find the following indefinite integrals. So just to practice here. So first example here, we have the integral of 3 dx. So as we said, the integral of a constant, it's going to be 3 times x. So this will be 3x plus c. Yeah, if you want to think about it as a 3 times, like integral of 3x to the power 0 dx, then this will be 3x to the power 0 plus 1 divided by 1 plus c. So this will give you 3x plus c. Of course, you don't need to write it this way, like 3x to the power 0. I'm just trying to explain this to you in case if you don't know the integral of the constant. Okay, same thing here. The next one, it's the integral of a 3 dt. That means we are integrating with respect to t. So in this case, I would expect my answer to be 3t plus c. And again, this is like it's like 3t to the power 0, and it's dt, and this, when you integrate it, it's like a 3t to the power 0 plus 1 divided by 1, which is 3t plus c. Okay, so for the next one here, I'll write underneath. Okay, for the next one here, we'll add 1 to the power, so this is 3x to the power 3 divided by 3 minus 4x, we'll add 1 to the power, so it becomes x squared divided by 2 plus 2x, yeah, plus c. And we can simplify these three goes together. This 2 goes with 2 here. So the final answer will be x cubed minus 2x squared plus 2x plus c. Okay, I'll just clean the board from here. Okay. Right, for the next one, same thing, 4t cubed. So we'll add 1 to the power and divide by the new power. I will write it down here just to get away from the answer on the screen. So this is going to be 4t to the power 4 divided by 4 minus 8. T squared plus 1, it's t to the power 3 divided by the new power, which is a 3, minus 4t, so t plus to the power 1 plus 1 is 4t squared divided by 2 plus 3t plus c. And if we cancel down, the 4 goes with the 4. 8 and 3, we can't cancel them down. 2 and 4. And yeah, so the answer in this case will be t to the power 4 minus 8 over 3 t cubed minus 2t squared plus 3t plus c. Okay, so that's the answer as well on the screen. And the last one here, what we need to do is just to make it easier to work it out, we have 1 over x to the power 4 dx. So in this case, we put x at the numerator at the top. So there's going to be x to the power minus 4, yeah, dx. And then we'll work it out as same way we did before. I'll just write them down underneath there. Oops. Okay. Right, so as we can see here, we have x to the power minus 4 dx. Then when we add 1 to the power, then this will be minus 4 plus 1 is minus 3. So x to the power minus 3 divided by minus 3. Okay, divided by minus 3. And plus c, which is the constant of the integration. Okay, determine the following. We have x to the power 1/2 dx. So this means to find, to solve this, we would say it's x to the power half plus 1, which is x to the power 3 over 2, divided by the new power, which is a 3 over 2, plus c. And when we divide by a fraction, we can flip it over. So this is going to be 2 over 3 x to the power 3 over 2 plus c. And for the next question here, which is the integral of x plus 1 over root x dx. So we will change this root x as x to the power half here. And when we put it at the numerator at the top, it will become as minus half, at the power minus half. Right. Sorry. Oops. Okay, so x to the power minus half multiplied by x plus 1 here. And then we multiply out the bracket, so this becomes x times x to the power minus half, and we go back to the rules of the power. When we multiply, we add the powers, so 1 minus half is half, so we get x to the power half, plus x to the power minus half times 1, which is x to the power minus half dx. And now to integrate, we will add 1 to the power here, so this is going to become x to the power 3 over 2 divided by 3 over 2. So this is going to be just the step before this, is x to the power 3 over 2 divided by 3 over 2 plus x to the power, now minus half plus 1 is half, 1/2. Yeah? So minus half plus 1 is 1/2 divided by half here, and so that means we can flip it over, so it will be 2 over 3 x to the power 3 over 2 plus 2x to the power 1/2 plus c. So that's what it is here. Okay, so another example here is, given that dy over dx equals x squared plus 1 over x squared, find the equation of the curve through the point 2, 0. So first of all, we need to integrate dy over dx. So the integration of dy over dx gives us y. And when we integrate, it's better to, we have this x squared at the bottom, we put it at the top as x to the power minus 2, and then we multiply inside the bracket. So basically this like x squared plus 1 times x to the power minus 2 dx, and this is x to the power minus 2 times x to the power 2 is x to the power 0, which means 1, plus x to the power minus 2 dx. So this is, x to the power 0 is 1 plus x to the power minus 2 dx. And then when we integrate, the constant here is 1, we don't need this. So when we integrate 1 dx, it means x plus minus 2 plus 1 is minus 1. So it's x to the power minus 1 divided by minus 1 plus c. So we end up as x minus x to the power minus 1 plus c. And that's what it is here. Okay? Now, because the curve passes through the point 2, 0, then we substitute the values of x and y, and each x is going to be, we'll substitute the value of 2, and the y is 0, and that will give us the value of c, which is minus 3 over 2. Then we can write the equation y equals, in terms of x and y, so y equals x minus x to the power minus 1 minus 3 over 2, which is the constant, which is the c. Okay, I hope that was clear. Thank you very much and take care.